Alright guys, here is a video of this last one explained because I felt a little guilty not having actually worked through this with you. So the nice thing in number 3 is that it is already factored. So unlike the one I showed you from my old notes where it showed you all the factoring steps for it, this is already factored. This is how it will be on the homework. So you just needed to actually jump right away to what you're going to split this into. Since it's a repeated factor, remember we have to write both versions of that. We have to write it if it had a multiplicity of 1, and then our second fraction would be if it had a multiplicity of 2. The problem with this one is that both of those are quadratics we can't factor, so both numerators have to have a linear factor. So the first one would be ax plus b, and the second one would be cx plus d. So those are both going to be linear because they both have quadratic bottoms, and we hadn't seen one like that in the notes today. So then we can jump to our step where we look at what each top needs to get the common denominator. So the first fraction only has one of the x squareds plus 1s, so it's going to need another x squared plus 1 to get the common denominator. And then the second fraction, be careful, this is where some of you messed up on the homework. That one already has the whole common denominator. It has x squared plus 1 squared. So that one doesn't get multiplied by anything. It's just going to stay dx plus d. So then the new thing that we're working out is that we are going to actually multiply these. So I'm going to distribute this first guy here. I'm going to get ax cubed plus ax plus bx squared plus b, and then it's going to be plus cx plus d. And then we're just playing the matching game for the rest of this. So the first thing I'm looking at is the cube. There's only one cubed, and there's only this, which has a 1 out in front of it. So that tells me the coefficient of that one cube thing has to be 1, because it's got to match what was already there. For the next one, I can match up the, we don't want to go to x yet. It's actually the x squared we want to match up next. So the x squared, there isn't one over here, so it's really 0x squared. So that tells me that b is going to be 0. And now the next one, I can match all the x's together. So this guy's x, and that guy's x. So that's going to be a plus c, that has to equal 3. But look, we already know what a is, so I can plug that in. 1 plus c equals 3, which means c is 2. And then the last step is all the things that don't have an x have to go together. So that's going to be b plus d has to equal 3. And we can plug in for b that's 0, because we already knew b, so it's d equals 3. So this one was actually a whole lot easier than the previous problem, than when we did number 2. So final answer here is just plugging all of those into that original equation. It's going to be 1x plus 0, which I'm not going to write, over x squared plus 1, plus 2x plus 3 over x squared plus 1 squared. That would be your final answer. So hopefully hearing it explained makes you understand a little bit better what's going on in a problem with a repeated quadratic factor.